because you can always build a perfect model for any data that you continue to look at. You can build exactly the right model that gets every little weird part of that data, but some weird little parts of that data aren't going to generalize to the rest of the world. Thank you guys so much for having me. I'm really excited to be talking today about a project that we've been working on at DataIku. So as was introduced, we are talking about predicting churn in World of Warcraft. Just to give you a little bit of an overview of what we're going to talk about today, first I'm going to introduce you guys to the game of World of Warcraft, at least briefly. I'm honestly a little horrified at how few of you have ever played the game, but that's fine, we can work with that. Then we're going to talk a little bit about what churn is and how to think about it, because it's not something that's actually defined in the data we're working at, so you have to be a little bit thoughtful. We'll get into the data itself a little bit, some of the ways that we chose to model it, and then what we learned from that modeling approach. So, getting started with World of Warcraft. It's a video game. I really hope everyone in the audience at least knew that, otherwise it's going to be a little bit of a rough talk. So it's what's called an MMORPG, which means that when somebody signs up, they sign up to be a character. And they're going to take that character, and they're first going to choose a bunch of things about that character. So we'll get into some of those details, because we're actually going to use those for features, is the kind of character you choose, predictive of whether or not you enjoy the game, whether or not you continue playing. But then once you've chosen your character, you go into a constructed world. You can interact live with other players, you can form alliances, you can go on missions, you can level up so you become stronger, faster, more sophisticated in the things you can do in the game. And also, you can take on different kinds of missions which can defeat you and set you back, or give you rewards and set you off on different kinds of paths. So it's interactive, it's exploratory, but it's also in some ways very goal-driven. Users try to reach a series of goals, they try to get better. So it's a game that was released by Blizzard Entertainment about 10 years ago. Despite you guys, it really is actually quite profitable and popular. And the way that the business model works is that players pay a monthly subscription. So you pay, and then you can log on as much as you want. So from the business perspective, it's very important for Blizzard to keep those players logging on periodically enough that they're willing to pay the fee every month. So we're interested in, the main question here is, can we predict which users are going to continue playing and which ones are going to quit? Just to give you guys a little bit of background for what we're talking about in the game, I'll introduce some terminology from World of Warcraft. So when you first sign up, you have to make a really important choice, which is, which faction are you? And this is basically, are you one of the good guys or are you one of the bad guys? Alliance versus Horde. Then you can pick a corresponding race. So you can be an elf, you can be a dwarf, you can be human, I think, indeed. And then you also can choose a class. And a class is sort of what your profession is. Are you a warrior? Are you a priest? Are you a blacksmith? And with all of these different choices comes different features in the game. So, elves are very quick, but they're not very strong. Blacksmiths are very good at making their own weapons. They're not that smart. So you can kind of choose how you want to optimize for the environment that you think you're going to be playing in. In terms of the goal-directedness of it and the things that can change throughout the game, so everyone starts at level 1. You can get all the way up until level 60. I think at some point they maybe released an expansion pack, so you could even do better than that. But 60 was for a while the max. And as I said, you can either treat this as a solo game or you can join with other teams. All of this is fluid. So levels change, who you're affiliated with, which we call guilds, as well as what region you're in can all change. So the environment is made up of different zones, which have, again, different properties. So there's some terrain that is hard to travel through, it's marshy, it's kind of gross. There's some terrain that has lots of enemies, there's some terrain that has lots of treasure you can find. So people can optimize for different environments, depending on what they're interested in. So, now that we all know what World of Warcraft is, what does it mean to predict churn in this environment? So, first, just to introduce the concept of churn. The idea behind churn is what percentage of users are leaving the game at any point in time. So as I said, when you have a business model that is a paying subscription, it's particularly important to keep users engaged. So actively predicting churn is going to be one of the main things that people on the marketing and sales side of Blizzard are interested in trying to figure out. Who is leaving the game? Why are they leaving it? And critically, what can they do to prevent those users from leaving or maybe lure them back once they've actually left? So yeah, that's really kind of the core question here. How can we answer that question when we're dealing with World of Warcraft data? So what we got is actually a really cool data set. It's publicly available. The URL is here and the slides will be posted, so you can go find it and play with it yourself if you're interested. It's a huge data set. It takes like a couple hours to download, so be prepared. And what it is, it's a real player data that was collected at 10-minute intervals for about 3 years. So that's quite a bit of data even for one user, and we have a little over 90,000 different users. So we have both a lot of temporal data and a lot of different users that we can try and generate features from. One of the things that's notable about this in terms of what we can do with it is it only comes from one of the specific realms, and it's only from one of the specific factions. So we have people who live in a certain geographical region because they tended to end up all on the same server in the online world, and everybody who chose to be a evil guy. So really what we are predicting is, with some geographical specificity, churn of evil World of Warcraft players. So what does the data look like? In some ways, even though we have a ton of it, the actual data is relatively sparse. So what we have to start is a timestamp. So remember, we're sampling every 10 minutes. And what we sample at those 10 minutes, first of all, is a sequence, which is where in this particular login cycle are they? So what 10-minute interval are we at? So we're looking at this person's 9th 10-minute interval. We're 90 minutes into their session. We're looking at an avatar ID. So this is how we track individual users across time. Everything's anonymized, but this is going to persist every single time they log in and out. So we can get a really long history of how a user is interacting with it. We know what guild they are currently part of, so this can change. Guild is who they're affiliated with as a team, who are they going on missions with, and so on. We know what level they're at, so how far they've progressed in the game. We know what race they've chosen, we know what class they've chosen, and we know what geographical zone they're currently in the game. So, based on this data alone, we're going to try and figure out who is going to keep paying to play the game and who's going to leave. One of the things that's particularly worth noting here is that in this, we already have to make a guess about what counts as a session. So we have these 10-minute timestamps, and we have this sequence, and we have to put together and say, okay, at what point did a user log off, and do we want to consider these separate sessions? And in fact, this is going to be a problem that persists at a bunch of different levels, because none of this is labeled data. We don't know whether a user is actively playing the game or whether they just logged on and maybe left their server open for a while. They don't have to pay for time, so it's no cost to them if they forget to turn it off. And more importantly, we don't have any information off the bat about whether or not a user has actually churned. All we have is these timestamps that say, for the times that they connected to the server, where are they, basically. So, the very first problem that we face when we're dealing with this data is defining the target variable, which is, did a user churn or not? So you'll notice indeed there's no churn column, but if we're trying to predict, if we're trying to build a predictive model, one of the first things that we need to know is which of our users churned and which of them didn't. Because if we don't have that information, we're not going to be very good at figuring out what predicted that and then generalizing to the future about users that we actually don't know. So this is, in terms of defining whether or not somebody has churned, this is the closest to the approach that we took. And then the other things you guys are mentioning are the sort of features that we tried to build in terms of predicting whether or not we could guess that they would churn. So how did we specifically do it? We tried to do it in a relatively data-driven way because, it's certainly possible that somebody continued to pay their subscription, but couldn't log on for a couple months because they got too busy at school or work, because they got sick, things like that. So how can we figure out what is a reasonable amount of time to have taken a break versus the amount of time that probably means that somebody's not using the game anymore? Now, obviously, if we had payment information, we could just look and say, oh, well, when did a user cancel their subscription? But one of the interesting challenges with this kind of public data is you often don't get personal information, including payment information. So we have to make a pretty good guess about when we think they probably decided to stop paying when they churned. So what we did is we said, let's look at, for every user, the longest period of time between login sessions. So how long was it from the log off all the way into the next log on? And then we looked at the distribution of these across users, and we picked a point that was around 15%, so in the tail out here. So the idea is we're trying to say that of all of these longest possible rest times, maybe the longest 15% start to be not that likely to be normal rest times, but maybe are actually exit periods. And that corresponds to 180 days, which we can kind of cross-check just intuitively. That's about half a year, 6 months. Again, that seems kind of reasonable that if someone hasn't logged in for 6 months, it's not clear we want to consider them an active user anymore. The subscription model, people can pay for a year, they can pay every month. And for example, if someone stopped logging in for 6 months, we don't know whether they're still paying every month and just haven't logged in, or whether or not on month 2 they canceled their subscription and therefore obviously didn't log in. So like I said, if we had the payment information, this wouldn't be an interesting question, but since we don't, we have to figure out what's the best way we can guess. It's tricky because, yeah, people will subscribe to a game they're no longer playing, so they've churned as a user, but they haven't churned as a payer. Definitely, it's a complicated space, but it seems like both in terms of the data and sort of in terms of human intuition, this is at least a pretty reasonable place to start. So specifically, the way that we define it is we say, so let's take a given month in our data set, and for each player, we're going to say, okay, were they active in the previous month? And then, all right, so that's if they weren't active in the previous month, we're going to look forward in time and say, if from this month we know in the data that they didn't log on for another 6 months, we're going to consider this an active churn. And one thing that's interesting about what we're building into the data here, and also that's true in the world, is users can churn and come back and churn and come back because it's this monthly subscription model. So as a business, Blizzard is also interested in making sure that users continue to persistently pay rather than paying for 1 month and then stopping for 6 months and then paying for another month. So we can treat churn in this case as sort of temporary churn, which gives us a little bit more space to say, okay, well, what predicts that someone is going to stop using for 6 months at some point or another, and can that give us information about the way to try and bring those users back in? So, given that we have now one way of defining our target variable, whether or not somebody churned, the next thing we want to ask is, what can we use in our data to figure out whether or not somebody is going to churn in that particular period of time? To start out, we really probably don't have enough information. Like I said, we know a little bit of information about that particular point in time, where they are and what they're doing, but that can't tell us very much about whether or not they're going to churn in the next 6 months. So, you guys already answered this a little bit, but I'll take some more ideas. What kinds of things from this data could we build in terms of trying to make a predictive model, whether or not someone's going to keep playing the game? So what we've heard so far is what level they're at, how long it's been since they last logged on. Maybe there was one more. Yeah?
Maybe how long their sequences are.
How long, okay.
To get shorter, maybe they're less interested.
Okay, yeah, so how long they're willing to log in and play for. Yeah?
Maybe how long they are already playing the game, like everything is reviewed.
Okay, yeah, so how long a user history they have. Yeah?
They haven't changed class or race for a long time, maybe?
So that is a good one, although if you do that, you have to start a new character, I think. at least in this data set, that's how we treated it. So you can change your guild and your location, but you can't change your race and your affiliation. So you'd have to restart the game, and so you would effectively have churned in this data set. Yeah.
So would that also change your avatar then as well?
Yeah, exactly. So you'd be, if you restart the game as a new character, you would be a new user in this data set.
That would mean that someone who churned wouldn't be an actual player. It would be an ID. Right.
Yeah, no, so it's definitely. So if people are switching characters a lot but continuing to pay, we won't be able to detect that in this data set, definitely. Yep. So yeah, so these are all excellent ideas, and basically we tried to do all of them. So what was the most we could possibly get out of this data set? So we were interested in getting information about the location they were hanging out in. So we tried to extract features about how many other users were in that same location, how popular was it, how long were they in this one zone. I think that was the other one that someone mentioned is, are they kind of stagnating or getting stuck, or are they moving around a lot? So in this data we could, so I guess one thing that's worth pointing out here that's really cool about this data is, so we have information about each of the individual users, which is what I've shown you, but we can reformat that data to think about getting statistics for all of these things, right? So I have, for every user, what zone were they hanging out in, which means that I can also say, oh, well, for every zone, how many users were in that particular zone this month? And so you can start to turn it around a little bit and say, okay, well, this user was in zone A. Zone A had 500 other people hanging out in it. Maybe that was actually a pretty good place to be. Versus this player was in zone B. There was only 2 other people there. Maybe it wasn't that cool after all. So that was one thing we tried to do, is extract geographical information that we could use to make guesses about the environment they were hanging out in. Then, as somebody mentioned, we tried to get a sense of how they were spending their time when they were logging on. So what we did is we calculated for every hour of the day and for every day of the week, what portion of their time on average were they logged into the game. So Monday morning at 10 a.m., what percentage of your time were you likely to be spending logged into World of Warcraft? So we could start to get a sense of when people were logging in and how they liked, to interact with the game. Then an obvious derivative of this, which somebody else mentioned, is how long were they logged in for? So how long did a single session persist? Are they someone who logs in for 10 minutes and then gets bored? Or are they one of the people who commit for like 8 hours and forget to eat lunch? Next thing we did is we also tried to get some information about the other users that they were interacting with. So as well as being able to collect statistics about the geographical zone they were in, we could also think about the group that they had affiliated themselves with. So the same way that we could think of a zone as how many users are involved in that zone, we could look at a guild and say, okay, how many users have joined that guild? How often are users changing in and out of that guild? What's effectively the churn of that guild? Suggesting, is it a group that's accomplishing a lot? Do people seem to have a good dynamic? Because remember, in a weird way, this was all very real. The people in your guild were the people that you talked with. They're the people that you were successful or not successful with. So if you talk to World of Warcraft users, the people that were in their guild were one of the defining experiences of whether it was a fun pro-social game, whether it was kind of aggressive, whether they felt like they were accomplishing a lot or not. So trying to define the social interactions, at least in a sort of primitive way, was another thing we were really interested in doing. And I think, this is in some ways a little bit of a toy example because we're dealing with a video game, but I think it's worth thinking about when you have this kind of user information, how can you turn it around so you can collect details about what they're interacting with. If somebody is always logging into a website, you can turn it around and say, oh, well, how many other people like to use this kind of website? Is it a popular website? Is it a website that people spend a lot of time on? And then you can learn some things both about the website and about that specific user because they logged into that website. So those are the kinds of things that we wanted to think about in this data that I think are actually pretty widely applicable to these kinds of use cases. And then the final thing that we were interested in, again, somebody already mentioned, which is somebody continuing to progress through their levels? Do they feel like they're making progress? Or have they gotten stuck because it got too hard, they're not spending enough time, whatever. So Just as a preview, I will show you guys the way that we actually did this inside of the data science studio that we have at DataIku, so you can start to get a little bit more detail of how we did this, but just to give kind of a sense of the high level. So these were the 5 types of features that we tried to build for our predictive model. So what do we do next? So one of the most important things when you're building a predictive model, especially when you're trying to project forward in time like this, is to be a little bit thoughtful about how you're going to train your model and how you're going to test your model, and then how you can apply that to data in the future. So once we've done all of our feature generation, we've built up this really nice data sets, we want to put into a machine learning model enough data that we think we can infer, okay, well, which of these features, like login time, popularity of guilds, percentage of people in your zone, are going to predict whether or not you churn. So we need a good amount of data to do that. But then we need some test data to see, well, okay, how well did our model actually how well did our model generalize to predict data that it didn't actually directly learn on? So this is always an important thing when you're doing any kind of predictive modeling, is you can build your model on one data set and you can explore it and do everything that you want and build the best possible model, but then you always have to test it on some data that the model has never seen. Because you can build a perfect model for any data that you continue to look at. You can build exactly the right model that gets every little weird part of that data, but some weird little parts of that data aren't going to generalize to the rest of the world. So if I say, all right, who's interested in coming to this talk, and I look just at this half of the room, I could give some description that would perfectly capture every single one of you. But then if I look at this half of the room, that's not going to generalize perfectly. So the goal with machine learning and predictive modeling is to figure out which of the features that are true in the first group actually are probably pretty true of the second group also. So the way we do that is we say, great, we're going to take a big chunk of our data to be the training data. That's this side of the room. Then we're going to take another chunk of the data to be our testing data. That's this side of the room. So we can get a sense of, okay, how well did we do on our tests? And then finally, we have what we call validation data, which is when you actually set your model loose into the world. So maybe in this case, the validation data would be the guys hanging out in the back of the room. I've trained my model, I've tested it, it did pretty well. If I let it loose, can it actually predict new people, the guys who came in a little bit late? So the way we did that here is we trained our data on data from 2006 and 2007. We tested it from the second half of 2007. And then we took one more year as validation data, so we could really get a sense of what would it be like to let our model loose in the world as new users started to sign up in 2008. In this case, we were working with data, last year, so it was obviously not 2008, but it's a way of trying to think a little bit about, okay, well, if you did let your model loose in the world, is it actually doing pretty well? So we usually want these 3 splits of data as best we can. Now, next question is, when you set up this kind of train and test and validation, what kind of machine learning algorithms do you actually want to use? And again, we're going to get a little bit more into the details when I zoom into the actual demo, but there's 2 different classes of algorithms that I was interested in looking at for this project. One is logistic regression, and so the idea behind logistic regression is you're building a really simple linear model. So you say, for every one of the people in your training group, we want to predict, are they going to churn? Are they not going to churn? And we can try and add up weights of their features. So we can say, okay, we know, these guys were elves and these guys were dwarves and these guys leveled up and these guys didn't. Can we put those together in a combination where you're just adding them together that predicts, reasonably well whether or not somebody's going to churn? And what's really nice about logistic regression is that it's very understandable. You can look exactly at each of the things you've added in and say, oh, okay, it turns out whether or not you were an elf versus a dwarf, that was really, really important. And in fact, if you were an elf, you were very likely to stay, but if you were a dwarf, you were pretty likely to churn. So it's a very interpretable model. The downside of it is that in terms of its machinery, it's not that sophisticated, so it can be a little bit dumb. It sometimes gives a little bit less predictive accuracy than different kinds of models. So So often, in fact, we'll run two together. We'll run a logistic regression because it gives us something that's really interpretable that we can explain to people. For example, the guys at Blizzard and say, look, like your dwarves really suck. You should probably improve the game experience for people who sign up as dwarves. But then what we also do is we run a class of tree-based algorithms. And the idea behind a tree-based algorithm is you say, in a little bit more of a sophisticated way, well, let's take our user group and split them up based on one of our variables. So we can divide them by elves versus dwarves, or above 30 versus below 30 in their level. But then you can keep stacking all of those little splits. So let's say we divide it up by elves versus dwarves, and then each of those two groups we could divide it differently. So maybe my elves I want to divide up by level, but my dwarves I actually want to divide up by geographical region. And then each of those subgroups I could divide up again and see if you can build up little groups where at the bottom everybody churned or everybody didn't churn. And so you can get these stacks of features and kind of long laborious descriptions of, well, dwarves over level 30 who hung out too much in the woods and never got a sword, they all churned. So, it's actually really predictive because then when a new guy who ends up in that situation gets fed through your model, you're like, oh, that guy's definitely gonna churn. But it's not that helpful when you're trying to say, well, what's bad about that user experience? Was it the sword? Was it the dwarf? And so if you can use the combination, you can take these kinds of tree-based models and say, okay, well, I can be really accurate. I can say for this new user, are they going to churn or not? And then I can look at other kinds of models and say, and the reason that they're probably going to churn is most likely because they chose a dwarf, and maybe a little bit because they didn't level up so much. And so we can kind of work back and forth to make good guesses and also explain to people why those guesses are good. So that was the approach that we took here. And then I think actually the next step really is going to be to dive a little bit into the actual model. So here we have our preparation steps. So I've connected to the raw data, so it's this 3 gigabyte download of all this different user data. And then I took a couple of different steps to clean it up. All right, so here is the live version of the thing that you were just seeing. Still can see it. All right, excellent. Here we have our preparation steps. So we've connected to the data here, which is just a straight upload. And then we're going to take a series of steps to kind of clean it up. So if we look at the raw data, you can see that it's, oh, I just lost my sound. Can you guys still hear me?
Yeah.
Kind of? All right. I will talk a little bit louder. So you can see that the data here is a little bit in a gross format. So we have, some kind of weird things appended. The column names aren't that attractive. We have this unpleasant date format. And so what we do is there's a bunch of steps that you can take inside of the studio. So here, for example, one of the things that I think is kind of cool is that we can take one of the dates. So here we have this date column, which was very hard to read. I don't know if you guys have ever worked with dates in Excel or in RStudio. It's genuinely a pain. And so what's kind of cool here is you can go to, thank you. You can go to the interface and say, great, this looks like a date column. I want to parse out my date. And so it will look at the data and it will say, okay, I'm going to make a best guess about which format is probably your data. So it looks like we have a year, a day, and a month. That's probably right. We can take a look at it. And then when we say okay, what we're going to get is the second column, which now has the date all nicely formatted across all of the different ways that it was configured. So this is just one example of the kinds of steps that we needed to do to clean it out. It's not that interesting to talk about, but it's definitely worth thinking about, because even when you get kind of a nice data download like we did from Blizzard, you still usually have to turn the data from kind of a gross text format into something that you can start doing modeling with. And so doing it in this kind of drag and drop way can actually be a really fast way to try and jump through some of those steps. So we did a couple of different steps to clean everything up. And then the part that I think is for our purposes a little bit more interesting is jumping into the feature generation. So if you remember, we had those 5 different arms of kinds of features, looking at things about the character themselves, looking at things about the geographical zone, etc. And each one of these arms is one of those steps. So, for example, this is actually just collecting the data that is the churn data. So this is where we define for each person, are we defining them as a churner or not, based on that metric that we set up. And just to give you guys a sense of how you could do that, with this, we actually just did it with a SQL recipe. So inside, as well as doing drop and drag, you can also do SQL and R and Python, kind of whatever language you're comfortable in. So in this case, it was really easy to work with SQL because we had a lot of data, but it wasn't very complex. And so we were able to say, okay, great, let's take all of our data, let's look at the current month we're in, let's look at the next 6 months in the future. If there's no login in those 6 months, we're gonna define that person as a churner. So that's what this script is doing. And for each one of the features that we built, we were able to take a series of steps like that and define programmatically, okay, let's look in the data and say, for example, how many people were in this zone at this particular time. Great, grab that number and store it in our database. So what we get at the end of the day is going to be a bunch of small data sets which have all of these different features, and we want to combine them together. And if we look at this big join recipe, it will give us a little bit of sense of what we actually did in the project. So what you're looking at here is an interface to combine all of these different data sets that we built together. This isn't all that interesting. It's just saying for every single feature that we built, how do we want to make sure that we're combining the right people at the right time? So for everyone, we're going to combine it on a combination of the month and the avatar ID. So that way, for every single month and every single person, we have some unique data about them that we've generated. So we're going to put all of our data back together based on that. And what data did we actually build? Well, so we can zoom in and get a little bit of a sense of the kinds of things that we tried to build. And again, I'm happy to talk about this in any more detail if you guys are interested afterward. But what we did for things like the session, so how long were they logged in for? So we were able to compute things like the days since the last connection, how long was it since they last logged in? And then what we did is we tried to divide things up into their own history. So we said, how many times in the last 10 days did they log on? How about in the last 30 or 60 or 180 days? So we got a sense of how often they were logging on. Then we could get information about the average length of their session. So how long were they spending every time they logged on? And then how long were they waiting between sessions, both as a maximum and an average, and then just the year, so that we got a sense of how this was changing over the course of time. So that's the way we defined how they were using it. Then for churn data, we already talked about this. This was just defining whether or not somebody churns in our definition of churn. For level, this is somebody mentioned that we could talk about how they're progressing, and that's exactly what we did. We say how many levels did they get through, again, in the last 10, 30, 60, and 180 days. So we get a sense of how quickly they're moving and how recent that movement has been in the course of their playing. With Zone, we were able to get information about the number of people in Zone, again, broken down by time. So maybe it matters that you had a lot of people in the last 10 days, but actually it could matter more that you have overall a lot of people in the last 6 months. We don't know, which is why we're including features on all of these different time scales. So this is another thing to think about when you're trying to define features yourself, is to say, well, do we care that this website was really, really popular just last weekend, or do we care that on average this website is pretty popular? And it might depend what you're trying to predict or what kind of user you're trying to interact with. But one thing that's kind of nice about a lot of our machine learning models is that we don't have to guess beforehand. We can just say, okay, let's make a hypothesis that number of users at some point in time might matter. We can calculate all of these different things and then see whether or not any of them actually are coming to bear as something that we care about. We did some other things. For example, for time, as I mentioned, we got the percentage of each hour in the day that they spent on the website. You'd honestly be kind of horrified at how high these percentages are for some people. Like if you look from like 9 p.m. to 1 a.m., there's like a set of users where that's like 100% basically across the board. It's kind of impressive. And then we also finally, as I mentioned, defined some information about the guild in a really similar way that we did for geographic zone. So we got some information about how many members, about how active those members were, how advanced those members are. So maybe you're hanging out in a guild with a lot of newbies, or maybe you're hanging out in a guild with a lot of really sophisticated high-level players. Does that change your experience? We got information about how quickly that community was changing. So on the scale of a couple of days, did a lot of people join or churn from that guild? So was it a really coherent group of people that did a lot of things together? Or is it a community where people would join and leave based on, whatever the adventure was of the day? So these are all of the different things that we built. And what we did when we put all of those together, just to give you a sense of how these data look, is we now had a gigantic data set. And one thing that's kind of cool about that is, if you remember what we had at the beginning, I showed you that screenshot, we only had 6 or 7 columns. So we had a lot of historic data, but not very much information. And from that data alone, we could generate all of these different things about this user's experience. And I think often when you are building a good machine learning model, this is one of the most important parts of this, is to be a little bit clever about how can you turn and twist your data so there's actually a lot more information there than you originally thought. And once you have that, it's not that hard to do the machine learning part because there's lots of nice interfaces at this point to do it. So as the final little bit of the talk, I'm going to show you one of the ways that we do the machine learning now that we've built all of these different features. So this final set of our workflow here is taking all of the data that we've built, so it's that massive data set that I just showed you. We're going to split it up in the way that I told you about. So we're going to take our training data from 2006 and the first half of 2007, and then we're going to build a machine learning model that's based on that data. And then finally, we can apply it to the data that we left out and see how well we did. So I think the thing that's most interesting from this perspective is to take a look at what our machine learning model actually is. So zooming out a little bit, these are all of the different kinds of models that I ran. So if you remember, I said that we wanted to run a bunch of different models for 2 reasons. One is because they tell us different things. So there's logistic regression, which will give us some information about how to think about our data, and there's the tree-based methods, which might be more effective. But then we can also just ask straightforwardly, well, which of these models did the best at predicting user churn? So we ran a gradient boosted tree, a logistic regression, a random forest, and XGBoost, extreme gradient boosting. Again, happy to get into the details of any of these algorithms if you guys are interested. One of the cool things about the Data Science Studio is that you can do all of this in a totally point-and-click way. So you can define, and in fact, the studio will make its best guess for you, what kind of prediction are you doing. You can get information about how you're splitting up your data. You can decide how you're going to treat your features. And you can choose all of the different parameters for your algorithms and how you want to compare them. So it's a really nice interface if you're starting to explore machine learning or if you want to quickly iterate through a bunch of different models. So we used this interface to train all of these different models, and we learned a couple of cool things. So first, one thing that you'll notice is that our accuracy metric, so this is area under the curve, is quite good. So it's actually, it turns out, with all of the data we generated, pretty possible to guess with something around, you can think of this as a little bit like accuracy, close to 90% accuracy, whether or not somebody is going to churn, which from a business perspective is spectacular. If you can say, for a user right now, there's 90% chance that they'll either continue paying you or not continue paying you, that gives the business a lot of information about where do they want to send their marketing, who are they going to intervene on, etc. So that's sort of overall something that was really cool about this project, is to say, using this real world data, we can actually do pretty well for a real business case. Then the final thing that is kind of cool that we can learn about is when we zoom into any one of our models, so this is one of our better performing ones, we can get in some information about what actually happened in that model. So if you remember, I told you the way tree-based models work is that it will split up the data in various ways and stack everything together. So we can just kind of get an intuitive sense of how that worked. So turns out in this tree, one of the things that mattered a lot was the days since the last connection. And the model found that the best point to split that was a day and a half. So it piled the users into people who had logged in the last day and a half and users that hadn't. And then it kept splitting those guys down in terms of, for example, the number of sessions in the last 180 days, the current level they were at, or over here, whether they had progressed in the last 2.5 days. So all sorts of very specific things that the model was able to converge on, you can start to build in. And then what's cool is you can zoom back out and you can get an overall sense and say, okay, well, of all of these things that got stacked together, which were the most predictive? And what we found is that really some of the things that kind of intuitively we already talked about really are the things that matter, which is cool from a marketing perspective, because now you have some data evidence that the things that we intervene on actually might be a really effective way to target users. So one thing that mattered maybe the most is the days since the last connection. That means if you see that a user hasn't logged in for a couple months, they're probably the people that you should send some marketing to and say, hey, don't forget about your account. You're the guy who's paying for 6 months but forgetting to pay. Why don't you log in and remind yourself how fun it is? So that's one of the most predictive variables. But also, for example, their current level. So it turns out that if somebody has already reached the max level, they're not that interested in playing anymore. And this is one of the reasons I think, for example, they released the expansion pack, is because if you find out that users aren't interested, they stop playing, you better be able to offer them something that's going to keep them engaged. Another thing that we found that mattered a lot, which again was intuitive but was kind of nice to see, is that the longer people were willing to play, the less likely they were to churn. So we find that the guy who plays for 4 or 5 hours in a row, he's probably not going to quit. And so maybe it's interesting then for developers to say, well, are there things we can do that keep people playing just a little bit longer? Can we turn those 15-minute sessions into 35-minute sessions? And then are people going to start to treat that as more of a regular way of playing? Now, obviously, you can argue maybe we don't want everybody playing, an extra 20 minutes a day of video games, but from Blizzard's perspective, that's definitely what they want. So, you can sort of think about how do you want to leverage this information when you're making these kinds of business decisions. One final thing that I think is kind of nice to think about and is cool to see in this interface is that depending on the kind of data you're working with, you might care about the balance of how correct you are in different kinds of ways. So what do I mean by that? So what we're looking at here is a confusion matrix. And it's a little goofy to read at first if you are not familiar with them, but you can read it this way. So actually 1 means which of the guys actually churned, and then actually 0, who stayed. And then how did our model predict that? So of the people who actually churned, it got about half of them right in this particular configuration. And of the people who didn't churn, it got a ton of them right. But maybe we want to change that. Maybe what we want is our model to capture all of the people who have a reasonably high chance of churning, and if we send some extra marketing material to the guys who are going to keep playing, that's fine. So for that, we can say, oh, well, we're interested in trying to increase this. Can we do a better job of capturing, oh, I'm going the wrong way. It's that number is not going the right direction. So if we change our threshold, then suddenly we can capture a much higher percentage, but we're going to make a few more errors also. So in a marketing situation, that's probably fine. It's okay to send a few extra emails. If you're doing cancer diagnosis, it's really, really bad to diagnose an extra 500 people with cancer. And so depending on your use case, it's interesting to think about, oh, okay, let's set the sensitivity of our model in different ways. Who are we trying to capture? Who do we care who falls through the cracks? What does it mean to be most accurate or most right? And that's kind of a nice way to play with your model, and you can get more sophisticated inferences without having to do anything super fancy. So I think that is really all I have sort of at the high level. Like I said, I'm happy to take questions or talk afterward. So let's see, will it ever come back? Yes. So I just wanted to close and say thank you guys very much, in particular to Growth Tribe for having us here, and for you guys for listening to me talk about World of Warcraft.